So this week we're going to be talking about this galaxy that the James Webb Telescope has observed, which is groundbreaking in that it is probably the oldest thing humanity has ever seen in a telescope, as it's about as old as the universe, and it is the most furthest object that we've ever seen in the night sky. We're going to talk about the Summer Solstice, what you expect to see in the sky, as well as the Strawberry Moon, which is a once-in-a-lifetime opportunity I want everyone to go at. If you're into astronomy or not, it's just a really cool thing to see. So we'll talk about that. And finally, we're going to be talking about solar weather, kind of reflecting on the May storms, what they actually did to us, and solar weather in the future, and how, it could impact, space exploration, and, how we're going to deal with that. We're going to be talking about that and more on this episode of Interstellar Insights. Alright guys, so before we get started on this first topic, I would like to just introduce myself. I'm your host Michael, and I'm currently a high schooler that really likes astronomy and astrophysics. It's something I'd like to go into college with. I just think looking at the cosmos is very cool. It's something that I've been fascinated for a while. I can't really remember the first time I really was fascinated by it. That's just how long ago it was. But hopefully with this podcast, I can connect with you guys, and we can talk about what's going on up in the cosmos right now, because what's going up in the cosmos right now is very cool, and I think people should just be fascinated by it, because we're seeing some really cool stuff, and I'd like to share that with you guys. So nevertheless, our first topic is we're going to be talking about the James Webb Telescope, because that just recently detected the most distant galaxy ever recorded. So that galaxy is called JADES-GS-Z14-0, which this is a little bit off topic, but astronomers, out of everyone in the world, I think they're the worst at naming stuff. Like these are just a bunch of numbers. Like, I'm sure JADES is an acronym, but like come on guys, like, it's too long. Like, they do this with other stuff. Like, if you guys have learned about Jupiter's moons, besides the Galilean moons, like Callisto, Ganymede, Io, Europa, the rest of the Jupiter's moons are just named like a letter and then the year they were discovered, like really boringly. But I digress. So, for the purposes of me saving my voice, so I can go on with this, I'm just going to call this galaxy JADES for short, because saying the full name is really annoying. But anyways, enough of that. So a little bit of background for you guys. So, like, the James Webb Telescope, if you guys don't know what that is, that's a deep space telescope. That was launched in 2021 as kind of a joint project between NASA, CSA, or the Canadian Space Agency, and the ESA, which is the European Space Agency, for a project between the US, Canada, and the EU. And so like that telescope was built to view celestial objects in deep space. So with that being said, the previous record holder before they discovered JADES was this galaxy called GN-Z11, and that was 13.4 billion light years away, and it had a redshift of 11.09. Now, to help you guys understand that, I'm going to explain what both of those means. So for those of you that don't know what light years is, light years is basically just the distance that light travels in a year across space. So for those of you that aren't physics oriented, light in a vacuum is like the fastest object in the universe, and that goes around 299 million meters per second. So that's like the fastest object in the universe, for those of you that aren't physics oriented. And so light year is basically period of time, so in this case a year, with the speed of light. So that basically is the distance covered. And I don't have the exact numbers here, but if you have ever been on a road trip across the US, I'd say, like, just imagine that, but like, I don't know, like 100 times, 100,000 times. Like, it's a pretty big amount of distance, and it's so big that it's kind of hard to come up with analogies, because we just can't comprehend it that much. So anyways, so GN-Z11, that was 13.4 billion light years away. So that was pretty far away. And then it had a redshift of 11.09. So in order to understand what redshift is for my non-physics people that are listening, I don't know why I think people should take physics. Physics is cool. It explains everything. Redshift is really just, if you guys know what the Doppler effect is, and if you don't know what that is, if let's just say you're on a raceway and you know how a car zooms past you, and as it goes by you, it goes faster, and then as it goes past you, it just quiets down. So that's what the Doppler effect is, and it can be explained the same way with light. So for those of you that don't know about the electromagnetic frequency scale, generally waves on the left that that are more wider, you can see on the scale that they're just more wider. Those waves tend to travel farther, but they don't carry that much energy. Those waves, just to clarify, on the scale, they look red, orange, kind of, and then the waves at the end of the scale, your purple and blue, just some examples, gamma rays is the primary example. Those waves have a lot of energy that they carry with them, but they don't travel as far. They dissipate quicker compared to your radio waves, which would be the waves on the left side of the scale, if you guys know what I mean. But basically, and then we'll have to go into a little bit of history for this. But if you guys don't know who Edwin Hubble is, Edwin Hubble was a astronomer, and his main claim of fame is that he discovered that the universe was expanding. So he did this around the 1920s, the 1930s. But anyways, as a part of that, he discovered the universe was expanding because of redshift. And basically, since the universe is expanding, objects are getting farther and farther away from us. And if you remember what I told you about, the purple waves, blue waves, and how they don't travel very far and they dissipate a lot quicker. Think about those waves. Imagine if a star went away further, you wouldn't be able to see blue or purple that much anymore. You'd see more red, because that's the primary wave that we're going to see because of that. So that's what redshift is. I guess to add on top of that, there is blue shift, where objects come closer to you, in which case you see more waves on the higher end of the electromagnetic spectrum, like your gamma rays, X-rays, things of that nature. You'd probably see more of those waves. But anyway, enough of me telling you about the science behind that. So the redshift scale, and we have to understand what the scale is, because it'll help you guys and me understand how far away this object truly is. Low redshift, which we will use a Z to represent redshift. If that's less than 1, that represents an object nearby within a few billion light years. So perfect example is the sun. The sun, there's very little redshift. I mean, if you guys don't believe me, it's just that the sun is naturally a very orange, it's an orange giant star. So that's just how it is. Anyways, so that's a perfect example. Or even some other nearby stars like Proxima Centauri or Alpha Centauri, the closest stars to Earth. So anyways, that's low redshift. Z is less than 1, with Z equaling redshift. So for objects with high redshift, Z is greater than 1. That represents very distant objects. So, farther out in the Milky Way, usually, far away nebula, star clusters. I was going to say Betelgeuse, but that that could be determined a different way because Betelgeuse is, a red supergiant. It's naturally red. But yeah, just like celestial objects outside of the local group, really. Those probably have a high redshift of Z is greater than 1. And then for objects with extremely high redshift, Z is greater than 10. Represents like pretty much objects as old as the universe itself. So, and just a reminder, the universe is 13.8 billion years old. So GN-Z11 had a I'm losing my train of thought now. It was 13.4 billion light years away, meaning it took 13.4 billion years for the light to hit Earth. So we're seeing that object the way as it was 13.4 billion years ago. So that's a really old object. This is for GN-Z11, by the way, not Jades. We're going to go into Jades a little bit later, but that's how old that object was. And at the time, that was like the oldest object that we've seen in the universe. But anyways, this record was shattered by Jades because oh, I'm losing my train of thought. Anyway, where are we going? Jades, yeah. So Jades is a little bit farther away than GN-Z11. It's still in the 13.4, 13.5 billion light years away from Earth. Wait, actually, no, let me rephrase that. So actually, Jades is 33 billion light years away from Earth. But it took about 13.4 billion years for the light to reach Earth, compared to GN-Z11, which I'm assuming, if we kind of compare the ratio, that's like, it's like almost, so like 7 billion light years for the light from GN-Z11 to hit Earth. But Jade's 33 billion light years away, so that's like essentially double the distance from GN-Z11. And for that light from Jades, it took 13.4 billion light years. So I was wrong about GN-Z11. That was 13.4 billion light years. Sorry about that. Just for any confusion. That's more like, if we do the quick math, that's more like it took, I would say, 6.5 to 7 billion years for that light to hit us on Earth. But anyway, I digress. So compared to GN-Z11, Jades has a redshift of 14.32. And if we look back at GN-Z11, that had a redshift of 11.09. So at that point, Jades is truly like the oldest object that we've seen in the night sky. It's arguably the oldest thing, humanity's seen in the night sky in quite a while. But yeah, it's a pretty old object. So yeah, I mean, because if the universe is 13.8 billion years old, and it took 13.4 billion years for the light to hit Earth, then that's about like at that point we're looking at like a proto galaxy, because remember how long it takes light to travel. We're basically seeing how old that object was in the sky by the amount of time it took for the light to reach Earth. So since it took 13.4 billion years for the light to reach Earth, we're basically seeing Jades how it was 13.4 billion light years ago. Well, anyways, that covers this portion of the show. Before we kind of move on to our next topic, I want to do something that I like to call the Sky Report, which I will talk to you about shortly, and what that is. Alright guys, so welcome to our next segment. This segment's going to be called Sky Report, because each week for a certain number of days, I'm I'm going to be basically reporting what's going up in the night sky as well as times for sunrise, sunset, moonrise, moonset. So today we're going to be talking about the big topics, of course. The summer solstice is coming up, and there's going to be a strawberry moon. That'll occur Thursday and Friday, so I'm only going to be talking about tonight, Thursday and Friday. But first off, I just want to get this out of the disclaimer. All the times I list are going to be in Eastern Daylight Time. So if you live out in Denver or LA or wherever you live, do the math, convert it to your time zone. I don't live there, so it's not my problem. Yeah, because living on the east coast of the U.S., use Eastern Standard, or in this case, Eastern Daylight. But anyways, let's get started with tonight. So Mercury will be up 2 degrees on the horizon, so it'll be very tricky to spot. But thankfully, it's got a magnitude of negative 1.8. This will occur 20 minutes after sunset, so yeah, that'll be tricky to spot since it's only 2 degrees high in the horizon. But good news is that throughout Thursday and Friday, we are expecting Mercury to climb up over the horizon. So even if you don't get to see Mercury on Wednesday, you can see it throughout the rest of the week. Besides that, a star, Pollux, which is very similar to the sun. It's an orangey yellow star like the sun. It's just a hair cooler. It's relatively the same size as well. It's like a giant star, but it will have a 1.2 magnitude. It'll be up in the sky, so be on the lookout for that. And a cool thing, binary star system's going to be up. The system is called Castor, and you can actually see both of the celestial bodies kind of split into two, but not really. The objects will respectively have 1.9 and 3 on the magnitude scale in the sky, and that'll be like a whitish blue color that you'll see in the sky. Anyway, that's for June 19th, and June 20th, summer solstice. That's big. Summer solstice will occur at 4:51 p.m. Eastern Daylight Time, converted to wherever you live. So basically, if you don't know, that's when the sun reaches its highest point in the northern hemisphere. So that'll occur at that time, and it's also going to be the longest night in the northern hemisphere. This is opposite for the southern hemisphere, where it's the winter solstice, and the sun will be that'll be the most farthest away the sun will be to the southern hemisphere, and it'll be the shortest day for them. Whereas here in the northern hemisphere, it's going to be the longest day. So because of that, there's not really much to see up in the sky, considering the amount of actual nightfall that you're getting is very small. So June 21st, in the early morning, around 4:30 a.m. Eastern Daylight, you can actually see Saturn and its moons actually kind of dance, because Saturn's moons are going to be congregating near its rings, and that's going to, I don't know if I already said it or I'm just repeating myself, but 4:30 a.m. Eastern time. On the southeastern horizon, you'll just see them dancing around. This will happen for a couple of hours until sunrise. And the most notable moon you can see is Tethys, and that'll kind of coast across Saturn, and you can kind of see its shadow off its rings. So that's going to occur early morning. So a lot of gung-ho people that really love stargazing probably going to go to that one. But the even bigger event that is going to happen that night is going to be June's strawberry moon. So this is kind of going to accompany kind of the summer solstice that happened the day before, but the moon that night is going to be a full moon, and it's going to be like this pinkish moon. So I'm sure if you've heard, it's not going to be like one of those blood moons you've heard about, but it's going to be kind of like pinkish strawberry color. Yeah, but I think that's something everyone should see. Even if you're not into stargazing, just, take a moment, go outside, capture it in, because it's like, once in a while kind of thing, kind of like with the Christmas star that happened a few years ago. But anyways, that's that for the week. So before we end this off, I'm just going to list some times. So for June 19th, actually, I'm not going to tell you the sunrise because that just happened by the time this is published. But sunset tonight is at 8:32 p.m. And then for the moon rise is going to be at 6:41 p.m. and moon set is going to be at 3:15 a.m. Note that those are for East Coast standard times, so it varies depending on your time zone. So be sure to check by yourself if you don't live on the East Coast. Anyways, June 20th, sunrise is going to be at 5:32 a.m. Sunset's going to be at 8:32 p.m. Moonrise is going to be at 7:49 p.m. and moonset is going to be at 3:52 a.m. June 21st, sunrise is going to be at 5:32 a.m. Sunset's going to be at 8:32 p.m. Moonrise is going to be at 8:52 p.m. and moonset is going to occur following day, 4:39 p.m. And I didn't clarify this before, but moonset, what I mean by that is it's going to happen the day after when the moon sets and kind of completes the day. Also, June 19th and the 20th are going to be waxing gibbous. Of course, June 21st is going to be the full moon, aka the strawberry moon. So, everyone should go see it. I don't care if you love astronomy or not. It's going to be really beautiful. I myself am going to go out. It's going to be great. Anyways, that is this week's Sky Report. I'll be doing this every week, just kind of analyzing what we can see in the sky for the following days, following Wednesday night, Thursday, Friday. But anyway, that is this week's Sky Report, and then let's move on to the next segment. All right, guys. So moving on to our next segment, we're going to be talking a little bit about kind of the past, present, and future of solar weather. So if you haven't paid attention, this May there's a bunch of solar storms that occurred, mainly solar flares and coronal mass ejections. I don't think it's so much CMEs, those more solar flares, but if you saw in the sky at night, that led to the aurora borealis effect. You could see it all the way down like Florida or like here in Maryland where I live. But yeah, so the thing about those storms is that the internet really kind of blew them up, mainly on like platforms like YouTube and TikTok, where people were like, it's the end of the world, we're all going to die, we're all going to be knocked back to the Stone Age and live like on the Flintstones or whatever. But that really wasn't the case, because many companies actually prepared ahead of time. So there's minimal damage. Telecommunications companies like T-Mobile, Xfinity, AT&T, they all prepared for that. And then, of course, our power companies prepared for that. And, all the necessary kind of bureaucratic agencies kind of got together and kind of put out a warning about it, like NOAA, NASA, organizations like that. So damage was actually minimal compared to what people on the internet were kind of telling people, saying like, oh, we're all going to die, we're literally going to be on the Flintstones, like that kind of stuff. Like that just never happened. Anyways, while it did happen in May, it's not going to be end of this kind of wave of solar storms that's kind of impacting us from the sun, because the sun has this solar cycle where basically its magnetic field changes very quickly, and it starts releasing out all this energy, mainly plasma. For those that don't know what solar flares and coronal mass ejections are, it's basically when the sun just erupts matter out into the cosmos. Because the sun is plasma. For those that don't know how stars work, they have a lot of hydrogen. They just convert it into helium to produce energy and stay alive. That's how stars work. So that's part of it. So we're kind of nearing the end of this solar weather cycle. It's going to last 2 more years before it reaches its solar maximum, or kind of like climax of the storm, and it's going to be in 2026. And that's going to be kind of a big year, because NASA is planning on launching the Artemis 3 mission to the moon around that time, which could be detrimental, because astronauts exposed on a spacewalk in space, they could potentially absorb like 1,000 times the amount of radiation our bodies can handle, which you don't need to be like a rocket scientist or have a PhD in astrophysics to say that that's really bad. I think that's like enough radiation kill like a town off, kind of like a Chernobyl. But anyways, I'm digressing here. It could get astronauts killed, and like it could also tamper with like the electronics and like space instruments like on the spacecraft. They could get damaged as a result of the radiation, and like that's just not something that's happened potentially to this spacecraft. During the May solar storms, Starlink, Elon Musk's internet satellite program, their satellites took some damage, but they were still operational. But if it's only going to get worse, we can expect the amount of damage to just increase. So NASA actually, to kind of figure out how they're going to deal with this, they invested in this program called the Center for All Clear Solar Energetic Particle Forecasts, abbreviated CLEAR, CLEAR Center, and it's basically going to help NASA track solar weather. So they could maybe push it back because the target launch time for Artemis 3 is 2026, but they might have to push it back if solar storms get worse, and that could put the lives of the crew in jeopardy as well as the spacecraft. But so that's kind of what's going on over there with Artemis 3, and like I said, it's expected to climax in 2026. That's when it'll reach its solar maximum, and the cycle will just restart. That's how it's always been. But anyways, it could be as bad as like the solar storm of 2012 that almost potentially knocked us back to the Stone Age, because there was a coronal mass ejection and Earth narrowly missed all that energy from the sun that could have knocked out. And by the way, this is getting a little bit hypothetical here, but if we were to get hit by like a coronal mass ejection or a really bad solar flare, that'll take out our kind of telecommunications infrastructure, so as electricity. So all the stuff we're relying on, computers, phones, knocked out. Iowa boys not being able to sell solar panels in the middle of Connecticut. If you know what that reference is. If you don't, go watch more pizza reviews. I'll just leave that at that. Okay, I'm going too far here, but anyways, yeah, it just gonna knock us back into the Stone Age, like the Flintstones, like I said. But if we had gotten hit by that solar storm, you guys wouldn't be hearing me talking to you about this stuff. So so expect more solar storms to kind of come on through, but it'll be I don't know. Only time will tell how bad storms will be. Anyways, when they do happen, always never a bad opportunity to go outside and see more aurora borealis or northern lights like we did in May. So go out there when they happen. Go see more aurora borealis. That's all I've got to say on that. As time goes on, we'll see what potential solar storms going to hit us and how that'll impact us. So that's all I've got to say for this segment. All right, guys. Well, that's the end of this week's episode of Interstellar Insights. Thank you guys for listening. Feel free to follow and subscribe. I'll be on both Spotify and YouTube podcast for now. If we grow more, I might expand outward, but for now, I think these two platforms are great. So we're going to go and stick with it. So this podcast every week, I'll be posting Wednesday unless I say so. But we'll be talking about news in the field of astronomy and astrophysics, and hope you guys stick around and talk about some pretty interesting stuff. Well, anyways, guys, thanks for listening, And I hope that you guys come back next week and listen again for episode 2. All right. See ya.